Thanks a lot for joining us. This is the first episode of our 5-part series about the journey of building our edit room. We really hope there's some useful information in here that helps you with your own setup, or at least saves you from a few of the mistakes we made along the way. And yeah, be gentle. It's my first time in front of the camera. I'm usually the one arranging people and images behind it, not standing here to talk into it. Who calls action? Hey, my name is Mike. I'm part of an independent filmmaking crew and I'm a visual storyteller working across still photography, digital and analog, filming, editing, cutting and color grading. For the past 3 years, I've been deeply involved in low-budget feature film production and post-production. And this year we decided we need a proper working space. We wanted to create a place to clearly separate work from private life and to build a focused creative environment. We had a rough idea of what should be done, but pretty quickly it became clear that we needed to dig much deeper, especially into the calculations, basics and physics behind acoustic treatment, because that ended up being the biggest and most critical part of the whole building process. After searching YouTube and Google for answers, we noticed that a lot of what we found wasn't really useful. People often just tell you what to do without ever doing it themselves. On top of that, you get a lot of product placements with really shitty results and a lot of "trust me, it works" advices they have probably actually never used, and we were like, what the I guess you get the point. That's why we decided to make a small YouTube series about our journey, right? Our goals were simple but a bit ambitious. One single room for editing stills, feature films, social media content, for meetings and for storing all our equipment. All of this had to fit into just 16 square meters while still being functional, comfortable and adaptable. So this should be more a real-world, low-budget approach to creating this multi-purpose studio than as saying, hey, do this or do that. So fasten your seatbelts and come along with us. We'll take you through every step of the process, from planning to our calculations, problems, compromises and of course the solutions. We will also show real measurements at every stage so you can clearly see what actually changed and what didn't. In the end, you can decide for yourself where you want to change something, set priorities differently, or the amount of work and money was really worth it. Okay, before buying anything, let's define our main goals here. For our room, we wanted to edit photos, cut video and do social media content, work on feature films, hold meetings and store all our gear. And all of that in one small space. We also wanted a solid reference spot to review footage and handle post-work, manage data from different projects and do final assemblies. In order to do that, a proper working space, color-accurate monitors and calibrated speakers were necessary. That's why acoustic treatment was inevitable. Maybe in practical, more chronological terms, this means first painting and finishing the walls, building the acoustic treatment, and after that moving in the furniture, bringing in the gear, and only at the very end, wiring everything up and setting the system live. For us, budget matters, so we try to spend it smart. First on what's essential to reach our goals, then on what's acceptable, and only after that on things that are nice to have. Maybe one important thing to get straight early on. Acoustic treatment is not soundproofing and equipment comes second. Start with what you already have, that's the easiest way. Maybe to start, first have a look what you already own. In our case, we had a pair of KK Rocket 6, a cheap audio interface we plan to replace later, 3 monitors, a desk with the right dimensions, storage shelves, and a lot of gear. That was our starting point. We also knew we wanted to add over time a couch, a custom-built shelf for our storage boxes, which includes a proper place for setting up a TV screen. And on the audio side, we decided to add a more accurate pair of studio monitors. After a lot of research, comparisons and listenings, we went with the Erdam A77H. At the same time, we wanted to keep the carrier case. We know their sound really well and plan to integrate them later into 5.1 setup. Along the way, we had a few conversations about priorities and timing. And pretty quickly, one thing became obvious. The room itself had to come first. We decided not to cheap out on acoustic treatment. Gear can always be replaced, upgraded or sold later. Walls, isolation and acoustic treatment are expensive, time-consuming and definitely not something you want to redo, especially not in a room with already packed electronics, lenses and cameras. The first step is obviously measuring, right? So measure the real dimensions of your room, length, width, height, and noting windows, doors, heaters, and so on and so on. Then we sketched everything first on paper and later in SketchUp, which is, by the way, also a free and really powerful tool where you can do 3-dimensional planning. For us, trying different setups on paper and in 3D was way easier than moving desks and panels around in real life. We marked our planned listening position, desk and storage zones, and tested multiple ideas. Desk, monitor placements, panel positions, storage solutions, even mock-ups for walls, corners and the ceiling. Seeing it all in 3D made it much easier to figure out what could actually fit, what would work acoustically, and where compromises were unavoidable. After all the planning and testing, we had a clear baseline that became the foundation for the rest of the build. So don't just guess, right? Measuring, sketching and testing in 3D first lets you see what works and what doesn't, and gives you a starting point for building, budgeting and prioritizing money without wasting time. Depending on your knowledge and experience, take some time to dig into the nerdy side of acoustics, measuring, calculating your room, and learning about treatment options. In our case, this was by far the biggest and most time-consuming part of the planning. We will leave you links in the description with different approaches, summaries and working solutions that helped us to get started. One tool we want to mention separately is AMROC. It's a free online room mode calculator where you simply enter your room dimensions and it shows you the expected room modes. Of course, this is not a one-to-one prediction of what will happen in your room. Real rooms behave differently depending on wall materials, construction, density, furniture and treatment. But AMROC gave us a very solid starting point and helped us understand where problems are likely to appear before we even started building. Once we had a better picture, we started calculating what we actually needed. The original idea was to flush mount the main speakers into combined corner bass traps, treat the first reflection points on the side, and the ceiling of course, and a back wall absorber. For a small room like ours, we knew there would be issues with room modes around 30-ish Hz and its multiples. So bass control had to be priority. We shortly considered DIY versus ready-made panels. DIY made more sense for us. It fits our oddly shaped room, gives more value for the budget and allows us to adapt the design to our needs. We also took our storage space into account, but that was mostly guessing and hoping. In acoustic treatment terms, there is really no way to plan that. Speaking of panels, there's actually another 3 tool that can help with planning, the Porous absorber calculator. It lets you calculate how effective an absorption panel is based on its thickness, air gap and airflow density, and helps estimate the target frequency range and behavior. You should aim at least for 0.6 NRC, actually even higher. This was really useful to double check our decisions before building anything. Maybe the big takeaway from all this is plan before spending. Calculating, sketching and researching first saves money, prevents regrets, and gives you a solid starting point for figuring out budget, materials, and how much you actually need. The theoretical correct layout is pretty straightforward on paper. The speakers should sit as close to the front wall as possible to reduce back wall reflections, and this should form a 60-degree angle to the listening position. That gives you an equilateral triangle between the 2 speakers and your head, which is the classical starting point for a solid stereo image. For the listening spot itself, a common reference is around 30% of the room length. measured from the front wall. So basically we're sitting the closest to. It's not a magic number, but it's a good place to start before you begin fine-tuning. The tweeter should be roughly at ear height or slightly above, actually, because that's where most speakers are designed to sound the most accurate. When it comes to angling the speakers, there are basically two main approaches. The first one is SOT, straight on or parallel angling. Here the speakers point straight forward, basically past your listening position instead of directly at it. This usually gives you a wider listening area, but the sweet spot is less focused and not as tight. Depending on the room, this can sometimes help with reflections or uneven acoustics, but imaging often feels a bit softer. The second approach is HAR, heavily angled toe-in. In this setup, the speakers are angled inwards towards the listener. Most of the time, this results in better stereo imaging, more focus and clearer center information. By aiming the tweeters more directly, you also reduce sidewall reflection and end up with a tighter, more controlled soundstage. But honestly, don't overthink it here. Try both. Measure, listen and move things around and see what actually works in your room, or let's say what you prefer more. There's no absolute right or wrong here. Only what helps you work better, and trust what you're hearing is the main criteria here. But even after all that planning, building, measuring and fine-tuning, we ran into problems we didn't see coming. The room reacted differently than our calculations predicted, and some changes actually made things worse before they got better. In the next episode, we will talk about what happens when theory hits reality and how we push the room to its limits to finally make it happen. So, see you next time.